Welcome back to our discussions of JavaScript. Today we're going to look at shallow and deep object copy in JavaScript. Now truly, this is an issue in all object-oriented programming languages, the distinction between shallow and deep copies. It's really an issue for all programming languages that have the concept of memory references. But object-oriented programming languages both have this issue and make it less evident that there is this issue. It doesn't affect us all the time until it does. Let's take a look. So the first example we're going to see here is going to show shallow copy. So I set up an object on starting at line 1, O. It has a name property, age property, and a function called toString. And then I make a shallow copy right here. And you can tell it's a shallow copy because when we do reference comparison, this is the same in Java. When I do reference comparison, these two references are the same. So I have two reference handles, right? O2 and O. Now, in common language, we refer to O and O2, these identifiers, as the object. But really, they're object references. So they contain a little chunk of memory that refers to a larger chunk of memory that really contains the object. That's what's happening here. This object is created, and O is set to refer to it. And this is just swapping references. They both contain the same reference, and they both, therefore, refer to the same memory location. So when we print it out unchanged, of course, we'll get what we expect. They print out the object values when you use the toString method. But O2 is a shallow copy, so when I change age on line 21 to 45 for object, notice it changes in both places because both O2 and O refer to the same memory location. So we can fix some of this issue with the code starting at line 25. I reset up the object again, same setup, Ted, age 30, and a method. And this time, instead of just making O2 set equal to O, as on line 9, I use the objects.assign method. Now, assign can take the object properties from the second parameter here and copy them into the first parameter's object. So you can essentially append an object onto another object. And we're doing that here, but we're starting with an empty object. Right? You can start out with a non-empty object and it will append O to this. But to do this type of somewhat deeper copy, this is the way to do it. Object.assign new object, and then this copies the properties over into that. So let's take a look. So I've set up the object. I did O2 object.assign, and then I change age. So let's take a look at object copy. Line 37, object copy. And so I changed the age to 45 of O, but O2 is remained unchanged. It's different memory location. O2 is referring to the same memory location. By the way, if I had done this test, line 12, console log, does O2 equal O1? They look like it to us, right? They have the same contents, but their references are different. So this line of code here would print false for this case, because that's a different memory location, and that's why age is now independent for O and O2. So even though object.assign has taken this object and has added the properties to this, it still has somewhat of a shallow copy nature to it. Let's change O2 a little bit, the definition of it. This time I insert an embedded object. And so when object.assign copies the fields over, it's doing another reference copy for stats, the stats object. So name and age are primitives. They inherently hold the memory that are required for the values that they hold. But object references they don't directly hold the memory. So this shallow copy of nested objects will cause the stats to be shared between the two objects that we create, even though we use object.assign. Look at line 56. I do object.assign and I change the age. Now the age is going to change when I print out the toString, but the height is going to be the same between the two because stats is a shallow copy in this result. So object.assign makes a shallow copy of nested objects. Line 61. So that's here. So e.toString, Ted 45, we print this out, age is 30. Notice these are independent of one another, but the height has changed to 120 for both of them because stats is a shallow copy within it. Let's fix it with the next code here. So I set up my object again, same way. This time I'll make a deeper copy. I'll do the top level copy O2, same way, take an empty object and assign O2's or O's objects into the new empty object and then refer O2 to it. And then I'll do another call to object.assign, taking O.stats and assigning it to this. So this will make another copy, a deep copy of this nested object, and put it in O2 stats. So that when I change the height and now finally make a deep copy, print them out, you can see that the height is now independent in both because I made a deep copy of that nested structure. So I've solved the problem for this really simple example. But objects can contain objects can contain objects. And everything that's not a primitive is an object in JavaScript. So the problem can get quite complicated if you really do have the issue. And again, most of the time this shallow copy doesn't really come up that much. But if it does, and it will when we start studying React, then we need a reliable way and hopefully an easy way of making deep copies of objects. You could write your own library method, by the way, to traverse an object. And every time you encounter a non-primitive field, go down into that and copy it as well. But luckily, there's a common library called Lodash. And the Lodash library has a lot of JavaScript functions in it. Now, as JavaScript has evolved over the years, a lot of the JavaScript standard library has incorporated some of Lodash in it. However, they haven't copied, as far as I know, Clone Deep. And what Clone Deep will do is traverse the object structure and clone it for you in its code, so it's already written. So Lodash is a common library, and I've included it here from a CDN network, and it's pretty simple. I'll show you how to do it in React too when we get to that. Let's take a look at how it works. So when the Lodash script is loaded, it attaches an underscore to the object script's window object. And object script's window object this is really where the Lodash name gets its name, right? It's an underscore. It's a Lodash. So it attaches Lodash to the window object. It's a global, or for us global, and all the methods in Lodash then are off that object. So clone deep.o, O2, and we can see this also fixes the method. But if we had nested objects within nested objects within nested objects, Lodash would traverse through all of those, doing a deep clone of all the objects that it finds. So when does shallow versus deep copy get to be a concern? It's not important in most cases, as we've discussed, and most of the time you can do it without thinking about it. But when we get into asynchronous programming, it becomes a concern. So asynchronous programming means that you might have more than one thread of execution operating on the same data at the same time, simultaneously, asynchronously. That is, you don't know when those activities exactly are taking place. You only know that they're happening simultaneously. Well, if you have shared data between two processes, and they're both, let's say, modifying and or reading that data, then shallow data can become a big problem because you get deep data inconsistencies when that happens. So that's why this is important, and that's going to come up in the next time we study React. Thank you.